Hi everybody, I'm Finlay. I'm part of the group Safe Landing for aviation workers, trying to get a more sustainable future for air travel. I'm here in Denmark, in Copenhagen, the past couple of days at a Contrails conference. And yeah, it's been organised by this group called CONCITO. And I've got Karsten here with me. Could you just introduce yourself, a bit of background to yourself and to your organisation?
Yeah, thank you. So my name is Karsten Capion. I work as a senior analyst in CONCITO. We work with climate change as a think tank, and I work with a lot of issues on climate, but among those on aviation. And I have a background in chemical engineering, and then I transitioned into energy systems analysis, spent 10 years doing that, and then I moved on to working with climate issues more broadly in the Danish Council of Climate Change, and now CONCITO.
Great. So it's really interested talking to Karsten because within our group, within aviation, something that's really important is what is possible with the fuels that we put into our aircraft. And we're quite interested in looking at the best use of resources, whether that's biomass or whether that's renewable electricity. And I noticed a few weeks ago you put out a report on the best use of clean electricity, and it had some really interesting conclusions. So can you kind of take us through a bit on what your objectives with that study were and what some of your conclusions were?
Yeah, so we did a two-staged report. First of all, we looked at what are the short-term effects of mandating these carbon-based e-fuels. So that's primarily in aviation where we see that now. And then longer term, do these fuels make sense? And what we found was that the electricity and the CO2 that we put into making these e-fuels can be better used in other ways. So the electricity, we can use that to displace fossil-based power generation, or do direct electrification like electric vehicles or heat pumps. And we can achieve up to 6 times the climate impact of doing that relative to making e-fuels. We can also, if we want to turn that electricity into hydrogen, we can use that hydrogen to make fertilizer instead, and we would achieve 50% more fossil emission reductions by doing that.
Yeah.
And so we can utilize the clean electricity better by other means. At the same time, we're not using that CO2, and we can take that CO2 and we can sequester it underground and gain the same climate benefit that we would have gotten if we turned that into e-fuels, which is great fossil fuels. So we arrive at the conclusion that we can get at least twice the climate benefit of using those two resources separately rather than combined.
Great. So this is obviously a little bit of a complicated area, so just try and break it down. So what we're sort of saying is, I think you're saying is, we should build as much renewable energy as possible, but then we need to prioritize how we use those green electrons that are coming out of that. And you're saying, like, as a priority, you put it into the electricity grid, and you can remove, if you can then remove fossil fuels producing electricity, that's going to be good. And then there's follow-on priorities from that are like powering electric cars, powering heat pumps in homes to get rid of fossil fuels there instead. And then moving on, you then maybe make some green hydrogen, maybe run some direct air capture, sucking carbon out of the air. But even when you do those, you're advising, don't go ahead and combine those things. Use the green hydrogen for, you're saying, steel or fertilizer, and just put the carbon you've captured into the ground. And for a given unit of electricity, you'll save more emissions.
Yes.
with that kind of process. So when we discuss, this is sort of a similar conclusion we've come to as a group. One sort of question that is asked is, if you think about aviation in the future, we're going to need electricity probably for everything, whether it's electric aircraft at small scale, hydrogen maybe in medium, and then long haul maybe the electro fuels, or even through biofuels we need energy. So should we not, if those are required to fly in the future, should aviation not be like scaling those now? How would you answer that question?
Exactly. That's a criticism we receive when we present the short-term argument. So what we set out was to study what are the long-term economics of doing that, of making e-fuels. taking into account that we'll see a massive technological development in these, bringing down the cost of electrolyzers, bringing down the cost of the synthesis plants that put these things together. Now, the analysis show that you need to capture carbon whether you want to make e-fuels or whether you want to take that carbon and store it underground to get the same kind of benefit by also the emissions from fossil fuels. So those costs are the same. And the cost of making the synthesis of combining clean energy and CO2 are comparable to the costs of putting CO2 underground plus the cost of refining. And so those costs are also roughly evening out, which leaves the cost of clean electricity on one hand and the cost of oil and the price of oil on the other. And what we find was that if e-fuels are to make economic sense in the long term, the price of electricity needs to be extremely low, and the cost of electricity, the price of oil needs to be very high. And that is a very unlikely combination, given that if we had very cheap, clean electricity available, we probably wouldn't see very high oil prices because we wouldn't be using oil for very much.
Yeah.
So we see declining demand for oil due to electrification of road transport, home heating, and so on. And that leads to a decline in demand, decline in prices. And so it's unlikely in a world that goes through a green transition that will end up in a scenario with future high oil prices. And so if we end up in a future with low oil prices, we'll need to get to less than $1 a kilo of hydrogen, half $1 a kilo of hydrogen, which is about less than the cost of fossil hydrogen we make today without paying for the emissions. And that is, according to many analysts, virtually impossible to achieve with green hydrogen.
Okay. I think for me, there's a nice story that comes out of this, because as an aviation worker, or even as someone that flies, it feels like we want to scale up this stuff, but I have like a real concern that if we push for too much green hydrogen and e-fuels for aviation, we bump up the demand versus the supply that's possible to build renewable electricity, and that makes electricity expensive. That makes it difficult for people to go about to drive an electric car to heat their home, and makes it a difficult economic situation for a lot of people, and maybe also slows down decarbonisation. And we're worried about the planet, and about having a future planet where we can travel and that we can enjoy. So I really like this idea of sort of breaking that link by saying, yes, we need renewable energy. We'll need it in the long run. Once it's abundant, we can use it for aviation. But in the meantime, let's prioritize it for stuff that will drive cost reductions for people, for society as a whole, which would be great to be part of as aviation, decarbonizing society and providing those wider benefits even for the majority of people who don't fly at all, right? So yeah, I'm starting to see that kind of clear way through, that flight through, and that's what's quite inspiring, because it's nice to have that kind of light bulb moment where you can see something that's practical and logical and will also be good for everybody as well. So
the interesting thing here is that it might not even in the long term be attractive to use electricity to make these e-fuels. But it's also very important to say that this is not an excuse to just continue fossil fuel use and not do anything else in aviation, because those negative emissions, sucking carbon out of the air and depositing underground, is going to be expensive, and much more expensive than what is currently being paid from those who use fossil jet fuel. And so we'll need to see operational efficiencies, more efficient airplane design, and in general, just less demand due to higher pricing of aviation.
Yeah, pricing of the emissions.
What is currently being seen. And then we point to a lot of the other low-hanging fruits, such as the contrails that should be avoided. And you can achieve a lot in the existing fossil fuels by hydrogen treating those. But that's perhaps
that's a topic for another day. Discussion. Well, yeah, thanks. I mean, thanks for sharing that with me. And yeah, thanks for hosting some of our organizations here the past couple of days. I've had a lot of fun, and I've learned a lot and been able to network with a lot of really great people. So yeah, it's been a pleasure. Thanks very much.
Happy to hear that. Thank you.